Hello friends, you are welcome to my YouTube channel JK Academy India. In previous video, we have discussed the EMF and torque equation for DC motors and different types of DC motors, series, shunt and compound wound. In this video, we will see the characteristic and applications of DC motors. Now the characteristic of DC motors. The performance of a DC motor can be easily judged from its characteristic curve known as motor characteristics. Motor are those curves, characteristic of motor are those curves which show the relation between the two quantities. On the basis of these quantities, following characteristics can be obtained. Speed and armature current characteristics. The curve drawn between speed and armature is known as the speed characteristics of the motor. Torque and armature current, when the curve is drawn for developed torque and versus the armature current, it is known as the electrical characteristic. And third is the speed torque characteristics, that is known as the mechanical characteristic. The graph is plotted speed versus torque developed in the armature T. Some important points must be kept in mind while discussing the motor characteristics. First, EB is proportional to N phi, where EB is the back EMF, N is the speed and phi is the flux produced in the motor. Or we can say that speed is inversely proportional to flux and speed is directly proportional to back EMF. Third, the torque developed in the motor is directly proportional to the flux produced and the armature current. There are two graphs showing the characteristics of shunt motor. This is the torque versus armature current. It is a linear, means the torque depends on the armature current, and here speed versus torque. Speed decreases slightly when torque increases. So to boost the torque, we need to supply more armature current. This is the mechanical characteristics and this is electrical characteristics of shunt motor. In case of series motor, in torque versus armature current, this is not a linear graph. Before saturation, the torque is not being developed. After slightly increasing the armature current, that is called saturation point. From this point, the same motor works like a shunt motor. But when we see the speed versus torque characteristic, the speed of DC series motor drastically reduces with increase in torque. This is the inversely proportional, inverse characteristic. Now, in s- compound wound DC motor, torque versus armature, there are three lines. This is for series compound wound, this is for shunt compound wound, and this is the different compound wound. So in this case, this graph is also not linear. After some point of time, increasing the armature current does not changes the torque developed by the motor. Torque is not being increasing after this point. If we see the speed versus torque characteristic in different compound wound, at certain speed the torque is minimum whether the speed is high. If torque increases, speed is also increases, means upon increasing the speed, torque is being increased. So this is very different from the series and shunt. Now we will see the applications and selection of DC motors. In applications of DC motor, as per the characteristics of DC motor, different types of DC motors are applied for different job as explained. Separately excited motor, very accurate speed can be obtained by this motor. Moreover, these motors are best suited where speed variation is required from very low to high. Motors are used in steel rolling mills, paper mills, diesel electric propulsion of ships. Shunt motors, uh, from the characteristic of shunt motor, we have seen that almost constant speed of the motor can be obtained. Therefore, where the speed between no load to full load has to be maintained almost constant, these motors are preferred. And where it is required to drive the load at various speeds are obtained by speed control method. We will see after this. And any one of the speed is required to maintain almost constant for relatively long period. As such, the shunt motors are most suitable for industrial drives such as lathe, drill, grinders, shapers, spinning and weaving machine, line shafts, and group drives. Now the series motor. From the characteristic of series motor, it reveals that variable speed motor. The speed is low at higher torques and vice versa. Moreover, a light load or at no load, the motor attains dangerously high speed. It is therefore where high torque is required at the time of starting to accelerate heavy loads quickly, or where the load is subjected to heavy fluctuation and speed is required to be adjusted automatically, there these series motors are used. And these motors are suitable for electric traction, train, cranes, elevators, vacuum cleaners, hair dryers, shaving machine, fans, and air compressors. Now, please note the series motor is always directly coupled with loads or coupled with gears. Belt loads are never applied to series motor because the belt may slip over the pulley or it may break. Then the motor will operate at light loads. At no load and will attain dangerously high speed which may damage the motor. Compound motors. The important characteristic of this motor is that the speed falls appreciably on heavy loads as in a series motor, but at light loads the maximum speed is limited to safe value. Therefore, where high torque is required at the time of starting and where load may be thrown off suddenly and where the load is subjected to heavy fluctuation, these compound wound motors are preferred. As such, the cumulative compound motors are best suited for punching, shearing machine, rolling mills, lift, mine hoists. Now, starting of DC motors. To start to start the DC motor, when it is switched on to the supply with full rated voltage, it draws heavy current during starting period, more than the rated value. This excessive current overheats the armature winding and may even damage the winding insulation. Therefore, during starting period, a resistance called starter is connected in series with the armature circuit to limit the starting current. So this is the necessity of DC motor starter. Under normal operating condition, voltage equation for a motor can be given as EB equals to V minus IaRa or IaRa equals to V minus EB. The armature current is given by the relation Ia equals to V minus EB upon Ra. When the motor is at rest, the induced EMF or back EMF in the armature is 0 and EB is proportional to N. Consequently, if the full voltage is applied across the motor terminal, the armature will draw a heavy current because in that case EB is 0, so I will be V upon Ra. Because armature resistance is relatively small, the heavy starting current has the following effects. It will blow out the fuses and prior to that may damage the insulation of armature winding due to excessive heat effect if starting period is more. Second, excessive voltage drop will occur in the line to which the motor is connected. Thus, the operation of other appliances connected to same line may be impaired or in some cases they may refuse to work or they may stop. To avoid this heavy current at start, a variable resistance is connected in series with the armature as shown here. This is called starter or starting resistance, and thus the armature current is limited to safe value by adding this resistor in armature circuit. Once the motor picks up the speed, EMF is built up and current is reduced to this value. After that, starting resistance is gradually reduced. Ultimately, whole of the resistance is taken out from the circuit when motor attains the normal speed. So when the motor attains the normal speed, this resistance becomes 0. There are different types of starters used to start the shunt, series and compound wound motors. Here in this figure we can see a 3-point starter for shunt motor. This is point A where armature is connected. This is point Z where field winding is connected, and this is point L from where the supply is given to the starter. This is the overload relay. It trips the motor during overloading, and this is the no volt relay coil which holds this handle during running. This is the spring. If motor is switched off, this no volt relay coil will de-energize and this small piece of iron will disengage, and this spring, due to this spring, the handle will come to off position. Here you can see 4-point shunt motor starter. This is also 4-point shunt motor starter. In 3-point starter there was only 1 point Z. In this, 1 point is extra or added, and one resistance is connected, or variable resistance is connected in series with the field winding for speed control purpose. Same thing is represented in this. So this is the variable resistance, and this is the 2-point starter normally used to start the series motor. In series motor there is only one winding connected in series with armature, so we have only 2 points A and L here. In compound wound there are 2 fields, one is series and one is resistance. Here series winding is shown in this, which is connected to A, and this is the shunt winding. So to start the motor, first you have to switch on this isolator or main switch. Then the current will flow from this circuit, and we have to move this handle on this points. So this is a heavy resistance strip, and some tapings are taken out to connect this handle. So current will flow from this direction to this via no load relay coil and this. So at the time of switching off, this no volt relay coil will de-energize and this small piece of iron will be disengaged, and because of this spring, handle comes to its initial position. So this is the working of starter to start the DC series motor. So thanks for watching.